Now I know you already know how to multiply. Like if I asked you this question, what is 2 times 3? I'm sure you would say 6. And the way I think about multiplying is like this. If I had two things and I stacked them like that, but I did it 3 times, two things are repeating 3 times. 2 plus 2 is 4, plus 2 is 6. Well, what is 2 times 4? That would just be 8, because 6 plus 2 is 8. And this always works. If I wanted to do another one that's just a little bit harder, 4 times 3 is equal to 12. If I had 4 things, 1, 2, 3, 4, and I did that 3 times, there's the second time that I have 4 things, and here's the third time that I have 4 things. Well, then the answer is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And that's because 4 plus 4 is 8, plus 4 again is 12. What you can do is make a table like this. It's called the multiplication table or a times table. What is 2 times 3? And you'd write the answer where the 2 row and the 3 column come together. So the answer would be 6. And then the other one we did was 4 times 3 equals 12. So 4 row 3. I'm supposed to put a 12 here. If I say 2 times anything, that's just the same as doubling it. So 2 times 1 is 2. 2 times 2 is 4. 2 times 4 is 8. 2 times 5 is doubling 5, so that's 10. 2 times 6 is doubling 6, so that's 12. 2 times 7 is doubling 7, so that's 14. 1 times 1 is 1. 1 times 2 is 2. 1 times 3 is 3. 1 times 4 is 4. 1 times 5 is 5. 1 times 6 is 6. 1 times 7 is 7. Do you draw your 7s that way? That's the way I draw my 7s. And that helps me keep them separate from 1s. But it doesn't matter which way you multiply things. For example, we showed that 2 3 times was equal to 1, 2, 3, 4, 5, 6. But if I did 3 2 times, that would also be 1, 2, 3, 4, 5, 6. So you see, 2 3 times is the same as 3 2 times. And I think to see the difference, I can change the color. So this one is 3 2 times. There's the white 3 and the black 3. And this one is 2 3 times. There's a white 2, a black 2, and a white 2. But they both end up being 6. You get the same answer because it's the same shape. It's a rectangle, and the rectangle is the same size. So that means when I do my multiplication table, if I know that 2 times 3 is 6, then that must be the same as 3 times 2, which is also 6. So that also means that any number times 2 is the same as doubling it. So 4 times 2 is 8, 5 times 2 is 10, 6 times 2 is 12, 7 times 2 is 14, 3 times 1 is 3, 4 times 1 is 4, 5 times 1 is 5, 6 times 1 is 6, 7 times 1 is 7. Let's do this one. 3 times 3 is 9. 3 times 4 is 12. 3 times 5 is 15. 3 times 6 is 18. 3 times 7 is 21. Now I'm going to fill the whole chart out now without saying the words. So if I start here, I have 1 times 1 is 1. And then as I go to the right, I'm just counting in normally. 1, 2, 3, 4, 5, 6, 7. And same here. 1, 2, 3, 4, 5, 6, 7. When I go this way, I'm skip counting by 2. 2, 4, 6, 8, 10, 12, 14. And the same when I go this way. 2, 4, 6, 8, 10, 12, 14. This is skip counting by 3. 3, 6, 9, 12, 15, 18, 21, and so on. So every row is skip counting, and every column is skip counting by a certain number. And this is really important because it means that multiplication is really just adding over and over again one way or another. What if someone asks me, well, what is a circle times a rectangle? That might seem like a very strange question, but for me, the answer has to be a circle that's stretched out like a rectangle. So this is a circle, this is a rectangle, and if you multiply them, you get a cylinder.